space lattice. As in the diagram you can see a figure like we have some cube. Okay, so what is a cube? It is nothing but a geometrical three-dimensional entity. This is geometrical three-dimensional entity which have total 8 corners. As you can see in the figure, in first figure there are small spheres which are in black colors. Okay, so that cube have 8 corners, 4 at the above side, 4 at the below side, and it have total 6 faces, 4 side faces and one at the above, one at the below. So I can say cube is nothing but a geometrical entity which have 8 corners and 6 faces, right? See, in second diagram we have denoted a diagram by 3 things. First one is a unit cell, second one is a space lattice, and third is a atom. Okay, so the space lattice is nothing but it is the arrangement of the atoms. As we can see in the second diagram, there is a pink sphere. That pink sphere is called, we can call it as an atom. Atoms are always in a sphere. Okay, so we can call it as atom, and we arrange that atom systematically. Okay, there is an equal gap, they are placed equally. Okay, so this arrangement, it is in three-dimensional structure. So if I arrange that atom in a three-dimensional structure, then it is a space lattice. Okay, and you can also see that we have arranged the cubes as there is a bluish cube which was stated as a unit cell. Okay, so in that side, that bluish cube have same cubes in its sides, and above it have again same 3 cubes, and below it have again same 4 cubes. Okay, so the arrangement of all these cubes is called space lattice, and only single cube, that is only single bluish cube, it is called unit cell. Means we will go to the definition. What it tells us, that unit cell means the smallest component of crystal structure. Crystal structure means space lattice. Unit cell is the smallest component of space lattice. Okay, we cannot go below that. It is the smallest component. Okay, and what is a space lattice? It is a three-dimensional pattern of atoms in a space, right? Means in space lattice we can arrange the atoms in a three-dimensional way, in x-axis, in y-axis, in a z-axis. Okay, you can see in the figure, you can get it. The total nature or the total structure is called space lattice, and what the minimum or what the smallest we have is a unit cell. Okay, it have 8 corners and 6 faces, right? We will move forward. Next, if that each atom which is in a pink sphere, okay, it's in a pink color, if I replace it by point, then that point is called lattice point, or you can simply say it is a corner atoms. Okay, then every point or the pink atom has identical surrounding. Okay, see, the spheres are equally placed, the spheres are systematically placed so that every sphere have the similar surrounding or identical surrounding. Okay, then the space lattice of various materials differ in size and shape of the unit cell. We can find the different shape of the unit cells and their sizes, okay, or the shapes. We will move forward. So this is one sub point, that is parameters of unit cell. How I can define the unit cell, or we can say how I can define the cube. As I said earlier, the cube have 8 corners and it have 6 faces. In this diagram also we can see the 8 corners. The spheres we have put it in the corners, 4 at the above, 4 at the below. Okay, so how I can define the parameter, how I can define the parameters of the cube, what it will have, or how I can draw the cube. To draw a cube I want something, that something is the parameters. You are getting on? If I want to draw a cube, I want its length, I want its breadth, I want its height, and I want the interfacial angles or inter-edge angles. Okay, as you see in the figure, there are three axes: x-axis, y-axis, z-axis. Means cube is a three-dimensional thing. Okay, and the parameters are like a, b, c, alpha, beta, and gamma. Okay, so we will go through one by one. In this only have the two things. First is the primitives, the edges of unit cell, that is x, y, and z direction. That is, in x direction we have a edge, in y direction we have b edge, and in z direction we have c edge. Those three edges, also called as the length, breadth, and height, these three things are combinedly called as the primitives. That is, the edges of unit cell like length, breadth, and height are called as a primitives. In figure we can see as an example A, B, and C. Okay, next, interfacial angles. We can see we have drawn some angles, that is alpha, beta, and gamma. These three angles are combinedly called as the interfacial angles. Here I can say alpha is the angle between edge B and C, beta is the angle between edge C and A, gamma is the angle between A and B. So combinedly these three angles are called as interfacial angles or inter-edge angles also. Okay. Then these primitives and interfacial angles, if we combine both, then we can combine it called as a lattice parameters or geometrical constants. Here see, these three angles means A, B, C, and three interfacial angles means alpha, beta, and gamma of unit cells are combinedly called as a lattice parameters or geometrical constants. So as I said earlier, thus by giving the value of axial length, that is A, B, C, and the angles, I can draw any form of unit cell. You are getting a point or not? So the parameters are nothing but the such things which can be used to draw the unit cells. By that parameter I can draw the unit cells. So just we have the two things. One is a primitive, that is A, B, and C, nothing but a length, breadth, and height. Interfacial angles are the angles between the faces, that is alpha, beta, and gamma. And they both length and angles are combinedly called as a lattice parameters or geometrical constants. Okay, we will move forward. So the main point, that is crystal structure, or we can say the space lattice. Okay, so it have four types. First, simple cubic structure, that is SC. Second, body centered cubic structure, that is BCC. Third, face centered cubic structure, that is FCC. Next, hexagonal close packed structure, that is HCP. Okay, next, so the first we have simple cubic structure, that is SC. See, we can first go through the diagrams. Okay, so in above diagram we can see there is a cube. Okay, and that cube have 8 corners and 6 faces. The black small spheres are there on the corner sides. Okay, so I can say in this figure we have total 8 corner atoms, nothing else. Okay, so what the definition says, in this type of structure atoms are located at the corners of the unit cell or cube. Only corner atoms, no face centered atoms, no body centered atoms, only 8 corner atoms. So the total number of corner atoms are 8, and the example is polonium. Okay, if I increase the size of the corner atom such that they are touching to the adjacent corner atoms, then it will be seen as in a figure. And if I want to cut my unit cell only, if I want to cut my unit cell only, then I can get a cross sectional view which is shown in the figure. Okay, then what we have seen, the simple cubic structure only have the 8 corner atoms. Okay, remember it. Next, we will have second point, that is body centered cubic structure, that is BCC. Okay, see, we will first go to the diagram. What we see in the diagram? In below diagram we have again a cube with 8 corners, 6 faces. Here we have a blue color spheres which are placed at the corners, means we have 8 corner atoms, and one single sphere which is placed at the center of the cube. That center sphere is called body centered atom. Okay, and what we are placed in the corners are called the corner atoms. Okay, so see in the above figure what we have done, we are increased the size of the sphere such that the corner atoms are touches the body centered atom. Corner atoms are touches the body centered atom. Okay, just a case is here that you increase the size of sphere such that every sphere have the same radius. Okay, every sphere must have the same radius, means the radius of the body centered atom and the radius of the corner atoms will be exactly same. Okay, so in this case the body centered atom, it touches the all corner atoms. Okay, if I cut only my unit cell, then I can get the cross sectional view what we can see in the below figure. So we are going through the theoretical part. What it says, in this type of structure, atoms are located at the corners of the unit cell or cube and one atom at a center. Okay, so we can count the atoms. Total corner atoms we have 1, 2, 3, 4, 5, 6, 7 and 8. So I can write total corner atoms are 8. How many in the body centered? We only have one, that is in white color. So I can write total body centered atom are 1. Where this structure is found, we have examples, that is lithium, sodium, potassium, tungsten and molybdenum. If I compare this structure with the first one, that is simple cubic structure, in simple cubic structure we only have the corner atoms. In this we have corner atoms plus one at a body center. Okay, remember this. Next we have third type, that is face centered cubic structure, that is FCC. Okay, again here we go through the first diagrams. Okay, so here you can see in left side we have a diagram, half diagram. In this again there is a cube with its 8 corners and 6 faces. Here again we have placed the some spheres which is in blue color at a corners. They are in 8 numbers, right? As there are 8 corners, there will be 8 atoms. And there are some other colored spheres also which are in violet color. Which are those and how many are those? They are total 6. And we also have total 6 faces of the cube. Means the each violet sphere is placed on each face. Each face and it is center of the face. Okay, so in this structure we have total 8 corner atoms and 6 face atoms. Okay, so what the theory says, in this type of structure atoms are located at the corner of the unit cell, we are located, and one atom on center of each face. So see, at the corners we have total 8 corners, we place 8 atoms in a blue color. So I have total number of corner atoms are 8. Okay, as our cubes have 6 faces. Okay, so I placed the violet color sphere at each face or at a center of each face. So we have total 6 face centered atom. You are getting or not? So the total number of corner atoms 8, total number of face centered atoms are 6. Here also if I increase the size of corner spheres and the face centered spheres, then here on a single face the center face atom touches the its corner atoms. Getting or not? The center face atom, it touches the corner atoms. Okay, so where this is found, it is in copper, it is in silver, it is in gold, it is in aluminium, it is in lead. Okay, if I compare this with the first two, in simple cubic we only have the 8 corners, in body centered we only have 8 corners plus 1 at body center. And in third FCC, we have 8 corners plus 6 face centered atoms. Okay, we will move to the next one. So this is something different. Okay, as in the figure we can say that it is something different. Okay, as in the above figure we can see, or we first go through the below figure. Okay, yes, there is something written like face centered atom, corner atom, and the body centered atom. Okay, so here this is the hexagonal structure. What we have seen in the last three, it is a cubical structure. What is meant by hexagon? The hexagon means it is also a geometrical entity in 3 dimensions. This will have the 12 corners, 6 at the above side, 6 at the below side, and it have total 8 faces. Which are those? There are total 8 faces. At the above we have hexagonal face, at below we have hexagonal face, means those two are the 2 hexagonal faces, and the sidewise faces are the rectangular faces. Those are total 6 faces, means the hexagonal structure have 12 corners and 8 faces, and there are 2 hexagonal faces, one at the above, one at the below, and 6 rectangular faces. Okay, so in this, see what is written there. In this type of structure, atom is placed at the 12 corner of hexagonal faces. So if I see the diagram in the left side, in the A, see what is there? We have total 6 spheres. Okay, 6 are in orange color, one is in a blue color. Those 6 are the corner atoms. Okay, you can see same in the right side figure. Those small spheres are placed on the corners. Okay, and there is a single small sphere at the center. That center sphere is nothing but the hexagonal face centered atom. And in the hexagonal structure, in inner side we have 3 body centered atoms, were denoted by arrow. Look at there. Okay, there are total 3 body centered atoms. And then if I count the total number of atoms, if I count the corners, then 1 2 3 4 5 6 at the upper side, same way 6 at the below side, means we have total corner atoms will be 12. How many face centered atom will be there? One at the upper hexagonal face, one at the below hexagonal face, means we have 2 face centered atom. And if I calculate the body centered atom, then we have only 3 at the inside the body. That is, total body centered atom will be 3. Are you getting or not? Means here we have total corner atoms 12, face centered atom 2, body centered atom 3. Okay, and the examples are like zinc, magnesium, lithium, and beryllium. Okay, and here in the above figure you can get what is a cross sectional view. You can get after taking only your unit cell, or by cutting your only single unit cell, you can get such a cross sectional view. Okay, we will move to the next one. We can have a comparison, because the students get somewhat what is going on, what I am telling. Okay, so you are not getting well at the first sight. Okay, so I can compare here all the 4, we can compare only at one site. Okay, so for seeing the figure, just go put side the theory part. Okay, in first figure and the first above figure, there are only 8 corner atoms. So we can say for simple cubic structure there are only 8 corner atoms, nothing else. For body centered cubic structure, corners are 8, which are in green color. Body centered is in a red color, which is only single one. Okay, for FCC, 8 corners in green color and 6 at the faces with a red color. Okay, and for SCP, what we have? The 12 at the 12 corners, which is in a green color. Body centered are in red color, and face center is at the center of the above face and the same way center of the below face. Okay, so here you can compare. For AC, only 8 corners. For BCC, 8 corners, 1 at body centered. For FCC, 8 corners, 6 at 6 faces. For SCP, we have 12 corners, 3 body centered and 2 face centered atoms. Okay.